Okay, today we're going to be talking about the gradient of a line, and I've mentioned this a few times in the earlier videos, but we're going to explore it in a bit more detail today. So the gradient is just a measure of how steep a line is. Now, we can have 4 different types of gradients. So the first one, that red line there, I want you to imagine that that's kind of like a hill, okay, and we're talking about a hill, and this car is going to drive from left to right. So this car is actually going to drive up the hill. So if the line is going up from left to right, that means we have a positive gradient. Okay, so now look at the blue line, the second one there. That line, if I had my car starting on the left-hand side, if he was driving now, he'd be going down the hill. So if you're going down from left to right, that means we have a negative gradient. All right, the purple line there, if we start our car on the left and he goes for a drive, he doesn't go up or down, he stays the same. So a horizontal line, something that's exactly horizontal, is going to have a 0 gradient. So we would say that the gradient is 0 in this case. And this one here, you can imagine if I had a guy trying to drive down a completely vertical hill, he'd run into a little bit of trouble. So we say that that is a gradient that's undefined, okay? That doesn't have a gradient at all. It's neither positive, negative, or a 0 gradient. So you need to know what all 4 of those are. Second thing we're going to do is we're going to learn how we calculate the gradient. Now the gradient, if you remember from our equation of a line, y equals mx plus c, remember the gradient was represented by the letter m. I'm actually not quite sure why the letter m is used. That might be something, if you're interested, you could look up or Google. But nevertheless, mathematically, when we talk about the gradient, we use the variable m. And the gradient is calculated by the rise divided by the run. Okay, so the rise just means the vertical distance of the line, and the run is talking about the horizontal distance. So if we take a look at this first line here and we want to calculate the gradient, what we do is we draw a right angle triangle basically. Now this, the horizontal distance, is the run, okay? And then this is the rise. So all we need to do is count, okay? How many squares are we going here? 1, 2, 3, 4, 5, 6. So this has a run of 6 and a rise of 1, 2, 3, 4, 5, 6. Okay, so the gradient would be equal to the rise of 6 over run of 6, and if I simplify that, my gradient in this case is just 1. Okay, let's try example B. In this case, my run is going to be 3, and my rise is going to be 1, 2, 3, 4, 5, 6. Okay, so in this case, the gradient is the rise, which is 6 over 3. When I simplify that, I get a gradient of 2. Now, if we compare those two, you can see that this gradient 2 is bigger than this gradient 1, and that means that the line is steeper. And you can see from those, if you were imagining you had to run up this hill or run up this hill, this one, B here, is a lot steeper, okay? So a higher gradient means we have a steeper line. Now for C, do you think it's going to have a gradient that is less than the first one or more than the first one? So do you think it has a gradient of less than 1 or more than 1? Try and guess just based on the steepness of the line. Okay, let's see if you are right. Now the important thing is you don't actually have to pick the 2 endpoints of the line. You can pick any 2 points on the line, and I'll show you why. Now, if we did pick the endpoints, we'd have a run here and our rise. So let's just work out. Our rise is 6 and our run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we've got a rise of 6 and a run of 12. So our gradient, let's just calculate it, is 6/12, which simplifies to a half. And that makes sense, right? Because this one is less steep than the first 2, and so the gradient is less. Now, what I said before about not having to pick the endpoints. Let me just pick a different color pen here so we can see it clearly. So say I picked, I don't know, this point here and this point here, and I drew in my triangle. Now it's important to pick points that are right on the points. Like, do you see how this one here is sort of in between this line? Don't pick that point. Pick something that is, you can clearly see is a point. So in this case, the rise is 2 and the run is 4. So if I calculated it that way, I would get rise over run, 2 over 4, which still simplifies to a half. Okay, so it doesn't matter which points you pick, because when you simplify, you'll get the same answer in the end. All right, let's do the last one together, D. Now D, you should recognize, hopefully, from the previous slide, that it is going down. So this is going to have a negative gradient. What happens when we have a negative is our run is 2. We go across, always go from left to right. But now we actually have to go down. So because we're going down, we can kind of say that our rise is -6, okay? So the gradient in this case is now going to be -6 over 2. Sorry, -6 over 2, which gives us a gradient of -3. Okay, so that's quite a steep negative gradient. Okay, sometimes you might not have the line drawn for you, and in this case, you could sketch the line if you wanted, or you could do it without sketching. So I'm going to show you both ways on the first example. Personally, I quite like having diagrams. So if I just sketch those 2 points, you don't have to do them exactly, but just think about where they might be. The point 2, 1, A, might be right here, and then so B, if B was 5, 5, it might be somewhere up here. Okay, and actually I'll write in what points those are. So 2, 1, and 5, 5. Okay, and I'll draw in my line. Okay, so now if I calculate my gradient, you have to sort of visualize a bit more. But the run is the horizontal distance, so we're talking about the x coordinates. So that means we're going from 2 to 5. And to go from 2 to 5, that means we have a run of 3. Okay? Now what you essentially did there for the run, so let's just write this here, rise over run, is you actually subtracted the second point, the x coordinate, from the first point. So we did 5 minus 2 to get a run of 3. Okay? Now with the rise, we're talking about the y coordinates. So let's just get a different color here so we can see. So the y coordinates go from 1 to 5. So from 1 to 5 would mean we have a rise of 4. And in fact, what we did is we took the second y point and we subtracted from it the first y point. Okay, so we get 5 minus 1 is 4, and then 5 minus 2 is 3. So that gives us a gradient of 4/3. And you can just leave it as a fraction as long as it's simplified. All right, try the second one on your own. You can do it with or without a sketch, and then I will walk you through it. Okay, so with a sketch, we've got the point 3, -4. So 3, and then I'm going to go down here for -4. So there's point C, 3, -4. And then I've got point D, which is at 1, 1. So it might just be here, 1, 1. D, which is 1, 1. So I'll draw my line in. Now, you should automatically say to yourself, oh, look, it's going down. I'm going to have a negative gradient. Okay, so be very careful. Okay, so I'm going to go from left to right, and then I'm going to go down. So from left to right, my x coordinates, I go from 1 to 3. So my run is 2. Now, my y coordinate, I go from 1 to -4. So I'm actually going down by 5. Okay, now if we were going to just calculate it like the way I did before, to get the rise, So to get the rise, what I did is I took my y coordinate, -4, and I subtracted my other y coordinate from it. Sorry, so -4 minus 1. And then, starting with that x coordinate, I did 3, take away the other x coordinate, -1. So that gave me -5 over 2. So my gradient is -5 over 2. And again, you can stop there because that fraction is in simplest form. Now we can use this to be able to find out the equation of a line just by looking at the line. So again, we know an equation of a line is y is equal to mx plus c. So we need to find out the gradient m, and we need to find out c. So because we've just learned about the gradient, let's take a look here. So the gradient, now remember I said just pick 2 points on the line. So I'll pick this point here and this point here and work out the rise and the run. Okay, the rise is 2 and the run is 2, so the gradient is 2 over 2, which is just 1. Now C is the y-intercept. So the y-intercept is right here. So this line crosses the y-axis at 2. Now I can just substitute in m and c into my equation to get y is equal to 1x plus 2, or just y is equal to x plus 2. And that's the equation of my line. Okay, so that's the end of today's video. Now you can write your summary and ask your question for tomorrow's lesson.